All right, today we are diving into one of the most incredible, maybe even unsettling technologies on the horizon, brain-computer interfaces. Let's get right into it.
Just think about it for a second. Forget spending years with textbooks and language apps. Imagine just knowing it. Or what if you could learn to play a musical instrument not in years, but in a matter of moments?
And here's the thing. This isn't just a cool thought experiment anymore. We are standing right on the edge of a revolution that is going to completely redefine what it even means to be human.
And if you're thinking this is all some niche, far-off idea, think again. Analysts have already valued this emerging industry at $400 billion. The future isn't just coming, it's being funded big time.
So how exactly are we going from science fiction to actual functioning reality? Well, first things first, let's get into how this whole thing actually works.
To really get a handle on what's coming, we've got to understand the core technology. So let's break down what a brain-computer interface, or BCI, really is.
Okay, at its heart, a BCI is basically a bridge. It connects the electrical signals in your brain, your actual thoughts, to a machine. It creates this two-way street for information to flow between your neurons and, say, a laptop.
Now, there are really two main ways to build this bridge. The invasive way means surgically placing these tiny, high-tech electrode arrays right into the brain. That gives you the clearest, most detailed signal. The other way is non-invasive, using things like caps or headsets that just read your brain waves from the outside. It's less precise for sure, but way, way easier to use.
And the hardware itself is just advancing at a wild pace. You've got implants like Neuralink's N1, you've got AI-powered EEG caps. The technology is getting smaller and way more powerful. We're even seeing these single chip systems like Columbia's Biask that pack 65,000 electrodes onto a chip the size of a postage stamp. It's incredible.
But, beyond all the cool tech, the real story is in the results. What's happening in medical trials today can only be described as, well, miracles.
Take this recent trial. A paralyzed military veteran gets an implant. And for the first time since his injury, he could control a computer, a smartphone, just by thinking, moving a cursor, sending a text, regaining a piece of his life that he thought was gone forever. And it's not just about moving things on a screen. For people who have lost the ability to speak, this tech is aiming to restore something even more fundamental, the ability to just talk.
So this was the huge challenge for scientists at UCSF and UC Berkeley. Could they take the silent internal monologue of a patient who couldn't speak and translate it directly into audible words?
The result was just stunning. A team at Stanford built what they call an inner speech decoder. It lets patients simply imagine they are speaking, and the BCI translates those thoughts into text at up to 150 words per minute. That's a totally normal, fluid speed for a conversation.
Okay, so movement, check. Speech, check. But what about something as deeply personal and complex as memory? The next big goal is creating what some are calling a memory prosthesis for people who've had brain injuries or strokes.
And in a recent trial, we got a glimpse of the potential. An AI-guided implant delivered these tiny, targeted zaps of electricity to the brain, and the results were staggering. You can see it right here. Patients with memory problems saw their recallability jump by 40%. 40%! So, look, the medical applications are clearly world-changing. But that's not where a technology like this stops. The next logical step isn't just healing, it's enhancement, supercharging the abilities of perfectly healthy minds.
So we move from restoring to upgrading. We're talking about something called neural training, where you could literally upload skills directly into your brain's memory circuits. Or imagine an AI co-pilot for your mind, helping you analyze problems and come up with ideas. And the end game? It could even be brain-to-brain networks, where people could share thoughts and concepts directly, mind to mind, no words needed.
And this is where things get really philosophical, right? It makes you wonder what it even means to know something. If you could just download the experience of a master surgeon, are you one? Where does the data end and your own actual identity begin?
Which brings us to our last and honestly probably the most important section, the ethical minefield. Because as we sprint into this new reality, we have to face the enormous choices that are coming with it.
It's this classic double-edged sword. You have to balance the incredible promise against some very real peril. For every person who might walk again, there's the risk of mental manipulation.
For every skill that could be made available to everyone, there's the danger of creating a brand new digital divide, but this time, it's biological.
And this is not some far-off sci-fi debate. Big organizations like UNESCO are already sounding the alarm. They've issued guidelines saying we have to protect mental privacy as a basic human right. They're calling for fair access, for a ban on using this for enhancement on kids, and above all, for rules that ensure your mind remains your own.
And we need to have this conversation right now, because the train has already left the station. Investment in this technology skyrocketed by 700% in just 7 years. This revolution isn't coming, it is already well underway.
Which leaves us with one last massive thought. As that line between our minds and our machines starts to blur, and eventually maybe disappears, the biggest question we're all going to have to answer is about our own identity. When your brain is connected to the cloud, who exactly are you?